Good evening.
Hello, how are you?
I'm all right. Let me just make this on the right screen that I actually want it on. Thought I'd get on nice and early just in case.
Sounds good. Hey, go cool. How are you doing?
Happy Thursday, everyone.
Happy Thursday.
This is actually my second webinar of the day. I had one at lunchtime UK time as well.
All right, you've got a full day.
Yeah. Hey, Ryan.
Hey.
All right, you should both have permissions for sharing your screens at this point. I'm just going to check a few of our options. I'm going to mute participants upon entry. We also turn off their ability to rename themselves. And in the chat functions, I'm just going to set it up so that they can chat only with the hosts. All right. We're going to wait a couple more minutes before I start up our YouTube live stream. We'll use YouTube to record the session. This is also being recorded on Zoom, which we just use as a backup. Before we allow our audience in, Gokul, I'm going to share with you the introductory script and also a page for any questions, so you can record questions that are coming in either from YouTube or from the chat on Zoom. All right, Ruth, Ryan, any questions from either of you before we begin?
Nope.
No, I think we're good.
All right.
Ryan, you're just dropping the presentation on your desktop. That's right.
Yeah, I just finished downloading, so I can share my screen now and pull it up if we like.
Yeah, let's give
The
that a
only thing
try.
I realized we didn't do, Ryan, was whether I'm going to introduce you with a bio, or whether you'll just introduce yourself.
I can introduce myself. That's fine.
Okay, cool.
All right, looks good. So you've got your slide shared full screen now. I'll speak briefly over this slide and then ask you to advance to the next slide so that I can make an announcement for our continuing education credits. And after that, I will turn it over to the two of you. And we're good on time now. We still have, I usually start the YouTube stream about 5 minutes early, which can be useful because some of our subscribers will just decide to tune in when they get a push notification from YouTube. We typically have 2 or 3 who do that.
Makes sense.
And I'll just leave the audience in the waiting room for the time being. Still a little bit early for them to be showing up. And Gokul, when we get to the end of the presentation, can I put you in charge of switching the option to allow the audience to unmute themselves again?
Yep.
All right, and that is found in the participants panel on the More button.
And the more.
It's like the 3 dots at the
Oh,
bottom
yeah.
of the, yeah.
Perfect. Yep, I can do that.
All right.
Ryan, I don't appear to have control at any point, so I'll just ask you to advance slides for my bits and then you can do your bits. Oh,
Try
no.
now. I just found the button, so try now.
Okay. It told me
Better?
I had control. I also don't want to change the slides
Well,
because we're in the middle.
I can put it back if you want.
Okay, so if I click, yeah, that moved.
Okay, and
Like a
then,
bit of a lag on it, but
and yeah, I can still control.
okay,
So that's good.
perfect, lovely. So it was you giving me control rather than me
Yeah.
asking for it. Ryan, do you want to introduce yourself first and then hand to me and I'll introduce myself and then go straight into our introduction?
Yeah, sure.
All right. So Ryan, you'll be speaking first to introduce yourself, and then Ruth will introduce herself.
Yeah,
Okay.
we'll do that after you've done your intro and the AIA thing.
All right, sounds good. All right, I'm going to go ahead and start our YouTube live stream. That is now live. And cool, I've just shared the link for the YouTube stream with you.
Perfect.
And for those of you who are joining us on YouTube, we will get started in about 5 minutes. Any last minute questions, Ruth or Ryan, before we get started? Still a couple of minutes out. For those of you joining us on YouTube, we will get started in 2 minutes. In the meantime, if you found this series of webinars useful, please like this video and subscribe to our channel. We hope to see you at more of these events in the future.
Andy, I just shared those again.
Got it. Thank you.
All right, we'll get started in 1 minute. Cool. Could you go ahead and start admitting folks from the waiting room?
All right, doing that.
My name is Nathaniel Jones, and I'd like to thank you for joining this webinar, Comfortable by Design, Developing the City of London Thermal Comfort Guidelines by Ruth Shulston and Ryan Danks. This webinar is hosted by the IBPSA-USA Research Committee with the goal to share new ideas from research to the building simulation community. If you have questions during this webinar, please type them into the chat window. At the end of the 40-minute presentation, I will unmute our audience on Zoom for a discussion with Ruth and Ryan. Next slide, please. AIA Continuing Education Credit is available for attending this webinar. Please email info@aiaeb.org with your AIA membership number to receive credit for attending today's event. And now, I would like to introduce Ryan Danks and Ruth Shulston. Ryan, go ahead.
Good afternoon, everybody. My name is Ryan Danks. I'm an associate and a senior engineer at RWDI. I've been working in the kind of master planning and urban design realm for about 10 years now, and along with Ruth, was one of the leaders on RWDI's side in the development of these guidelines.
Good evening, everybody. My name's Ruth Shilston. I'm also an associate here at RWDI, working out of our UK office. I'm also a senior project manager working in our project delivery team. I've worked doing climate aware design and thermal modeling in the built environment for around 15 years now. And I will kick off today's presentation. Ryan, it's now not letting me advance the slides, so I might have to ask you to click one on. There we go. So what are we going to cover today? I'm going to kick off today's talk by talking a little bit about the motivation behind the guidelines. I work day to day on projects in London, which is the focus of today's talk. And then Ryan is going to delve really into the technical aspects of the talk. So what is thermal comfort and how is it measured? What can we as designers actually influence the specific simulation methodology which went into the guidelines? And then I will finish up with a number of case studies of actual projects that we've applied the City of London guidelines. And it has now let me click on. So the motivation behind creating the City of London guidelines. So London, where I am fortunate enough to live, is a world-class city. We often think of cities as places where people live, people work, but they are in many ways brands in their own right, and they have to compete on a global stage. So London is competing with the likes of New York, with the likes of LA and San Francisco in North America, but also with Paris and Berlin, Hong Kong, Beijing. It's a world-class city, and it wants to be seen that way. And what London has realized, or the City of London Corporation, who ultimately make the big decisions in the city, is that the quality of the public realm is part of that attraction. The city boasts amazing historic architecture, and it has some incredible new modern buildings coming forward. And those buildings are driven by a desire for major corporations to want to have their headquarters here, as well as being a major tourist destination. So the City of London became really engaged with and really focused on the quality of public realm. And as I'll go on to talk about, that's sort of what the motivation behind these guidelines were. So in the UK, we have quite a strict planning or permitting process for new buildings. So across the whole of the UK, not just London, if you undertake to build a new building, be that a simple extension to your house all the way up to a 300-meter high tower, you have to go through a permitting process and get approvals. And for the larger scale developments, which is generally the sort of projects RWDI would get involved in, you are generally required to undertake a wind microclimate assessment, as well as what we call a daylight, sunlight, and overshadowing assessment. And in the UK, there's no specific regulation around how these assessments should be undertaken, although the planning process itself is regulated. But there are a number of industry standard guidelines that have been developed, which either cover the whole of the UK or cover specific parts of the UK. And the two guidelines that are up on the screen here today are the two guidelines that govern how we undertake a daylight, sunlight and overshadowing or a wind assessment. So the City of London initially became interested in the quality of the public realm just from a wind point of view. So wind assessments have been undertaken, wind microclimate assessments have been undertaken on projects probably for the last 10 to 15 years. And the City of London, which is in particular the financial district, sort of modern downtown area of London, has had an explosion of tall towers in that time. And there were a number of towers which brought with them a reputation for being windy, for being uncomfortable. And the City of London came to realize that although they had a wind microclimate assessment undertaken on each of these schemes, that each scheme had used a different methodology, be that computational fluid dynamics modeling or physical wind tunnel testing. They were using different versions of the assessment criteria, which in the UK is the Lawson comfort criteria, but there are many different versions out there. And simple things such as results were presented using different color scales. So that made it really challenging for the city officers to really understand those results. So they worked with RWDI leading up to 2019. We put in place with them the wind microclimate guidelines specifically for the City of London. And these guidelines set out a minimum methodology for undertaking wind microclimate assessment. And it sets standards such as ensuring everyone's using the same climate data, same color scale, same assessment criteria, and sets up minimum standards for computational fluid dynamics modeling and physical testing. And for the UK, this is the first location that's had a set of guidelines that said how you should undertake a wind microclimate assessment. Everyone knows that one should be undertaken, but there were no guidelines for how one should be undertaken. If we go on to daylight, sunlight, and overshadowing, this is a more nationwide set of guidelines that's been developed by Paul Littlefair, who's at the BRE, which is the Building Research Establishment, which is a sort of ex-government funded body in the UK. And this set of guidelines has been around for quite a number of years, and it's the nationwide methodology that's used for not only consideration of overshadowing of the public realm, but it also looks at actually the amount of daylight that gets into a building. So if I was designing a new residential scheme, for example, we'd want to ensure that all of the kitchens and the dining rooms had sufficient natural light to be an enjoyable and pleasant residence for someone to spend time in. Actually, for interest's sake, these guidelines specifically state that they are not intended to be used as an assessment for planning, but somehow they have become the sort of industry standard nonetheless. And a revised version of these is actually due out imminently. From a public realm point of view, the specific assessment that this guideline sets out is that an amenity space, and when we say amenity in the UK planning process, we mean a park or a public terrace or a cafe seating area, a space where someone might want to sit and enjoy sitting for a long period of time. That space should get at least 2 hours of direct sunlight on the 21st of March over 50% of its area, which is my personal view is not actually a very robust or strong way of considering quality of daylight or sunlight in our public realm. But that is nonetheless the guidelines that we currently have. So if we move on to the next slide, one of the fundamental components of the UK planning process is that each of these assessments is undertaken independently. So RWDI might be the wind consultant and the daylight, sunlight, overshadowing consultant, but historically the two assessments are undertaken completely separately with completely separate reports. And it's actually very, very challenging for the planning officer to look at the wind results and the daylight, sunlight, overshadowing results and to combine the two together to actually have a consideration of whether a space truly is comfortable and whether a new development, a new tower, will adversely impact an existing space. So for this reason, the City of London came back to RWDI and said, well, we'd like to have developed new guidelines that build on the wind guidelines that have been really successful to create new guidelines that better measure how comfortable an external space actually is. And that's what brought us onto this topic of thermal comfort. So RWDI were the lead authors of these guidelines. We did a lot of work with the city, running simulations, which you can see on the far left of the screen, where we simulated wind and solar, as well as taking temperature and humidity data to give thermal comfort across the entire city area. And I guess one of the features of London, which might be quite interesting for this North American audience, is just quite how seemingly random our streetscape is. We certainly don't have a grid pattern. It's a very historic street pattern. And we worked with the city to help them to understand what conditions are like currently and the various different ways, which Ryan will talk through, that we can measure thermal comfort. And we put together a proposed methodology, and that was taken out to the industry. And you can see a list of firms down the middle of the page here. And these are the firms that gave us really robust feedback on how they felt the guidelines read, on what they thought about the methodology, how appropriate they found it. And actually that feedback was then incorporated into the guidelines, which the City of London then finalized to include all of the policy and regulatory aspects of the guidelines that they're responsible for, because ultimately it's a City of London authored document. And with that sort of brief history lesson, I'm going to pass over to Ryan, who's going to talk in a little bit more detail about the thermal comfort aspects.
Thanks, Ruth. Yeah, so in the next few sections, I'll be exploring kind of what we mean when we're talking about thermal comfort, the different ways we can measure it, why we even want to bother with it from a technical standpoint, and really the different ways we can manipulate it. And then I will dive into sort of a high-level overview of the methodology itself. I'm going to keep this section fairly high level too. This is an IBPSA webinar after all. I'm sure most people on here have at least some understanding of what we mean when we're talking about thermal comfort. But really, when we scale up to the urban realm, in a perfect world, what we'd be able to do is look at the entire environmental impact of a building in a holistic sense and come up with some way to grade that impact based on how people would perceive it. As Ruth's been alluding to, right now, we don't really do that. We look at glare separately from wind, separately from sun. And one of the big wins of these thermal comfort guidelines is taking a step toward that more holistic assessment of a building's impact. We're now looking at sort of the combined effects of at least sun and wind. And thermal comfort was a good place to start because it's been studied for decades. We have no shortage of different ways to score an environment from a human thermal perspective. You know, at its simplest, we have metrics like humidex and wind chill. Indoors, we have the PMV scale, which has the advantage of that very simple to understand scale, where 0 is comfortable, and then as you move positive or negative, things get hotter or colder. The problem is we can't extend that outside. People have different expectations. The range of climate parameters are different. PMV just doesn't work outside. So more commonly, we're using equivalent temperature metrics like UTCI, SET, or PET. And these can come with their own challenges too. UTCI includes some assumptions that can make it difficult to work with. And all three of those metrics, the equivalent temperature is actually an equivalent indoor temperature. And in our experience in consulting with these metrics, that can require a lot of coaching on our part to make our clients understand that. A lot of people think it works similar to humidex or wind chill, where it's basically an outside temperature getting hotter, and that they would be able to measure this, UTCI of 35 degrees outside. And it can challenge their kind of ability to understand what that really means. But as we'll see a little bit later, with these guidelines for London, we were able to come to a workaround to try and make these results a little easier to understand for the general public. And why the question may be, why do we even bother doing this? Ruth mentioned a few reasons from sort of a branding, big picture perspective, but I mean, there are financial and considerations too. Cities spend a lot of money to make sure or to maintain their public realm and their parks and trail systems. And so even if we add just a few weeks in spring and fall, even if we're just stretching the envelope of time that things are comfortable, that's a big win. No one expects these guidelines to make things perfectly comfortable year round. But if we can add a few weeks where our parks are more usable, or businesses can take advantage of outdoor dining, that's a big win. There is an environmental justice aspect to this as well. Not everyone can afford to drive in a climate-controlled vehicle around the city or have their own little private garden to enjoy. People have to walk, people have to take the bus and wait for it. People need to use our public parks to get their daily dose of green space, which, as we all know, is so important. So by making sure our public realm is comfortable, that can actually mean a reasonably good quality of life improvement for many people in our cities. So hopefully I've convinced you that this was a good idea to actually study this. But then the natural question is, well, what can we actually do at the planning stages to try to make things more comfortable? And when we talk about urban scale thermal comfort, there's sort of this hierarchy of strategies that we can use. The ones at the bottom of the pyramid have the largest area of effect, but are the least flexible. The ones at the top have better flexibility. They can be turned on or off or moved, but they influence a much smaller area. So if we work our way up this pyramid, the biggest sort of lever we have is the actual orientation and layout of our buildings and our streets. Now, in the context of a planning permission in London for a single building, this is not something we normally have much control over. Street layout is defined, the building footprint is fairly constrained. But if you're working on a larger master plan or a campus, it is important to know that through some thoughtful arrangement of your streets and your buildings, you can have a high degree of control over a large area, how much sun and wind they're exposed to, and therefore their thermal comfort. But in the context of the London guidelines, really manipulating the massing of the building is sort of our most powerful tool in our toolkit. And we have known for years how buildings can interact with wind and sun. If you put them too close together under certain orientations, you'll get the Venturi effect and winds will accelerate. Tall buildings, buildings that are much taller than their surrounds, will drive winds down. Or if the winds tend to blow from another direction, you can create areas of calm. We can ventilate courtyards by creating pass-throughs so that wind doesn't stagnate inside them. Same for sun. The example on the right here is a project from Studio Gang in New York, where they carved away massing of the building to improve solar access down at grade. These are all things that people know. The new kind of paradigm we need to be thinking about, though, is balancing these things together. Because we've always treated sun and wind as separate things, it's led to a lot of binary thinking where we always want to reduce winds and we always want to increase sun. And that isn't always going to be the case. Depending on where you are and what time of year you're talking about, a little bit of wind or a little bit of shade might actually be good. So it's this idea of balance and thinking in a more holistic, big picture sort of way that we're really hoping to drive forward with these guidelines. If we move up on another level, now we're looking at smaller scale interventions that you would add if massing was relatively fixed, or if you've done all you could from a massing standpoint. Very similar to the previous discussion, trees, canopies, windscreens, we know how these things interact with wind and sun, but it's the idea of balance we need to remember too. If you're putting up a large windscreen, you don't necessarily want to make it opaque so that you can get winter sunlight to keep things warm. At this scale, we're also now starting to get into measures that could potentially be operable. And that provides some very useful potential benefits. Windscreens can be rolled out as needed, opening up the space the rest of the time. You can use patio umbrellas to allow people a sense of control over their environment, which there's been some research that has shown that this has a positive psychological effect on people, makes them more tolerant of their environment when they have a sense of control. Even thoughtfully landscaping to provide a diversity of thermal comfort conditions can be really positive. It allows someone, again, that choice, that sense of control, to choose what sort of an environment they're sitting in. I can choose to sit someplace sunny or someplace windy. And then at the top of the pyramid, we've got what we're calling active measures. These are thermal comfort enhancement strategies that require an outside source of energy. So these are misting systems, spill air, patio heaters. And these cannot be your primary approach to mitigating thermal comfort. In fact, in the context of the guidelines, these are explicitly disallowed. You have to do as much as you can passively first And then the building owner can elect to use these measures as sort of a backup, or for cases where conditions are particularly extreme. But again, it's important, these can't just be plunked down anywhere. These also need thoughtful design. There's no point putting a misting system or a patio heater in an area that's going to be very windy. You're just going to completely dilute that impact, and it doesn't serve any purpose. So active measures can be useful. They cannot be your primary source of thermal comfort mitigation. And even if you are going to use them, they still need thoughtful design. So having gone through all that, I'm now going to dive into a high-level overview of the methodology itself. If you want all the gory details, I mean, there's the IBPSA paper that we wrote for last year's conference. But for the purposes of this webinar, I'm going to keep things fairly high level. And kind of the most important thing to understand about these guidelines is that they are, at their core, a planning tool. We're not claiming that this is, the most sophisticated or particularly novel approach to looking at thermal comfort. But what we needed was a tool that could create consistent and actionable measures for the planning department. So, no, we're not doing detailed representation of surface temperatures. We're not looking at transpiration from trees or plants. We're focusing on what the building mass can do to the public realm. And that allows us to eliminate a whole lot of assumptions that would need to be made in order to conduct these studies, things that may not even be well known at the time of planning. And by removing those assumptions, we make things simpler for the people who are conducting these studies and the owners who have to pay for them, which means we don't disrupt the current workflow too badly, which was important. But it also, by removing the assumptions, we remove the opportunity for game playing. As soon as someone introduces guidelines or rules, there's going to be people out there who try to find loopholes. And the fewer avenues for that game playing, the better, because we want to make sure we're getting consistent results. Planners want to be making sure they're always comparing different schemes using the same yardstick. So that kind of boils down our thermal comfort equation to this. We combine MET data with simulations of wind and sun to get thermal comfort. On the climate data side, we needed to deviate a little bit from how things are commonly done in the UK, in that we actually have to use a time history of climate data rather than sort of the more traditional Weibull statistics for wind. We need to know multiple parameters simultaneously, so we have to use a time history. We also aren't necessarily able to use the typical year files. In the UK, they're called test reference years. And the reason for that is we want to look at things seasonally. And there's often just not enough data once you've accounted for when certain spaces are likely to be used by season to have a good statistical understanding of when spaces will be comfortable. And that's never mind the fact that the weighting schemes for those typical year files don't really prioritize wind. So the wind data, especially as you get down to seasonal scales, can be kind of suspect. And so what we're looking at here is kind of a comparison of the data that we helped the city generate compared to a test reference year for London. And I should say that this, the data set for the city that we used was the most recent 5 years available from the EU's Copernicus atmospheric modeling system. So a data set taken right over the city from 2015 to 2019. And it did include things like the urban heat island aspects of the city, but not necessarily sort of the smaller scale interactions of the city with the climate. And when we compare the temperature charts, they look pretty similar, which you'd expect because temperatures are weighted quite highly in those typical year files. But if we look on the left, the wind roses are quite different. These are the winter winds for London. And these are often the most challenging from a thermal comfort perspective. And that black line is where the 5 meter per second wind contours should be based on decades of historic data for the city. So that's kind of this greeny color right here. And if we look at the 5 years of data we used for the thermal comfort guidelines, we're seeing a pretty good match. We're matching sort of the distribution of directions pretty well. Speeds match well. We're not doing great in the rarer wind directions, but those super rare directions aren't really what we care about with thermal comfort. We're focused on what are the most common conditions. And really, once you factor in the other parameters, this lack of a very rare wind case doesn't matter all that much. And then you can compare that to the test reference year, which between the sparse data set and the low prioritization of winds in the algorithm, it's all over the place. The speeds don't match, the distribution of speeds don't, directions don't match, not a very useful source of data. So that was why we helped the city create this data. And as we did with the wind guidelines, create a common reference point for all the firms who are doing these studies to work from. As I mentioned, the advantage of this file is it's also able to take advantage of London's heat island effect, at least in a gross sense. And by taking the most recent 5 years, we've also captured several extreme cold and extreme heat conditions that happened in the city, which allows us to an extent, acknowledge climate change without needing to use prognostic techniques, which again, introduce assumptions that we were looking to avoid. So once we have our climate data, now we need to conduct our simulations. For wind, because the wind guidelines had been published just the year prior, we really didn't need to write very much in the guidelines about how the wind aspect of these studies should be conducted. This provided us with basically a fit for purpose approach for doing wind assessments. So if your simulations were compliant with the wind guidelines, they will be compliant for the thermal comfort guidelines. So this is a nice, efficient way to reuse that data in the planning process. About the only variation was an explicit preference for CFD and computational approaches in the thermal comfort guidelines. And that was really just so we could get a better spatial resolution at the ground. That's not something you can really do with wind tunnel test points. And it is more important for thermal comfort since that can vary spatially much more quickly. On the solar side, however, we had to depart quite a bit from existing practice. Ruth alluded earlier that the current approach isn't necessarily very robust. And so we really needed to work a lot with in bringing up the standard for conducting a solar study. So hour by hour simulations, proper view factors onto people for looking at the direct component, and using a more reasonable representation of the diffuse radiation coming from the sky. In standard daylight requirements in the UK, you use the distribution here in the upper right. That's the CIE standard overcast sky. Very handy to use because you can compute daylight factors by hand if you need to with this. But this distribution of energy is entirely fictitious. There's probably never been a sky with this distribution of radiation. And given London's cloudy climate, understanding that proper distribution of diffuse energy is actually pretty important. So the big requirement we had in the thermal comfort guidelines to try and remedy this was a requirement to use a more modern energy distribution that will vary hour by hour as you go through the MET record and distributes that energy in a more realistic sort of way. The model we're showing here is the model from Perez. So we've got a central zone that's brighter because that's where the sun is, and then the brightening at the horizon because of reflections. And so this really was the biggest departure from existing practice, but hopefully it's one that we'll start seeing employed elsewhere because it really does a much better job at understanding those direct and diffuse solar heat components of the mean radiant temperature. And then lastly, I'll touch on our choice of metric. So there's no shortage of them, as I said. We settled on using UTCI. And there were a few reasons for that. The first was that this is a fairly recently developed metric. So there's lots and lots of available literature on its development. And a lot of those papers are freely available. So it is maybe a bit more transparent than some of the other metrics we could have chosen. It's also available as sort of a high order polynomial function, which is computationally more efficient, than some of the other metrics where you have to actually compute that human thermal heat balance hour by hour. And when we're talking about domains that are hundreds and hundreds of meters in radius, that speed up becomes very important. It's also a nice metric because it takes people out of the equation. It makes assumptions about what they're doing and what they're wearing. And so again, that removes an avenue for game playing. We're only looking at the building now. You can't, nudge up somebody's clothing level to make results look better. Now, UTCI is not without its faults or challenges, particularly those assumptions about people. In this work, they're pretty reasonable, but you need to be careful because those clothing assumptions are highly Eurocentric. You'd never want to use UTCI in the Middle East, for example. The clothing levels just wouldn't work. Another issue we ran into was sort of the categorization of these UTCI bands. If we had selected sort of the no thermal stress as our target range and run that through our metadata, what we found was that half the time in the summer, it would be too hot, and 9 days out of 10 in the winter, it'd be too cold, which didn't match anybody's expectations or experience in the city, either within RWDI's UK office or at the city itself. So what we did was start nudging up the range that we considered appropriate. This has been done in literature by others. And ultimately what we found was if we added a category on either side, suddenly our predictions of how often things would be comfortable started matching up with people's expectations and more sophisticated metrics like SET. Now, in a perfect world, this sort of a study would have been accompanied by survey data and that sort of thing. But unfortunately, the limitations of our project meant we couldn't do that. But hopefully in the future, that could be an avenue for future work. And the reason we went to the trouble of trying to properly establish a band that could be considered acceptable is because that's a much easier way to deal with these results by just showing how often a space is in that acceptable band. We have now abstracted out our thermal comfort metric entirely and reframed this in something that's a lot easier for people to understand. We don't need to talk about temperatures anymore. We can just say, well, over here, it's comfortable 90% of the time, over here, it's comfortable 60% of the time. It also allows for easy comparisons because you can do a before and after and just subtract to see what the difference is. Now, ultimately, the city planners wanted a sort of bottom line result that they could focus on. So what we ended up doing was creating a categorization based on those percentage of time things were comfortable by season. So it works very similarly to Lawson in that depending on how often a space is comfortable, we describe a kind of use that that space would be appropriate. So the most comfortable spaces we called all season. So ideally, these would be places like parks. Our seasonal spaces are where we've relaxed the requirement in winter. So, this would be something like an outdoor dining terrace where maybe people tend not to want to sit out there in the winter anyway. So it's not as important for it to be comfortable as frequently. Short-term and short-term seasonal are spaces where people aren't expected to linger for long, or if they are, that doesn't happen very often. So this is, unsheltered bus stops, entranceways, even office terraces where it's just for the office workers, have them be able to go out, get some fresh air for a little bit and go back inside. And then our least comfortable or least often comfortable spaces we call transient. So we wouldn't want to see these in any places where a person would want to linger. But if they occur on roads or in back of house areas, that's probably not a big deal. And the nice thing is that we can combine these categories with a knowledge of what's going on to assess a building's impact. If a new building changes let's say an outdoor dining area from a seasonal down to short-term seasonal or even transient, that's a major issue that we flagged and that the building will now have to correct because otherwise we've kind of ruined the utility of that space. It also allows us to do nice trade-offs between existing and future spaces. Like everywhere else, London is building more roof and terrace level amenity space and replacing ground level amenity space. But that's not really a fair trade if it's not as comfortable. So with this approach, we can look at how comfortable the ground level space is now and how comfortable your above grade space will be to make sure that the new space is at least as good or ideally better than what you had before. And on that, I will hand things back to Ruth for some case studies.
Thanks so much, Ryan. So these guidelines were launched in December of 2020. So they've been in force for about a year. Although the City of London, because they knew they were coming forward and a number of the consultants who fed into the guidelines were active on projects, there were a number of projects that was sort of snuck in before the guidelines were officially launched. So there are two projects I'd like to feature. The first one is 2 Finsbury Avenue, the image of which you can see on the left-hand side of our screen. This is a commercial tower. It sits at about 35 stories for the taller part of the tower, and then it's got a podium linked to, I think it's about a 20-story is the lower tower. And this sits right to the north of the City of London in an area called the Broadgate Estate. And the Broadgate Estate is a historic sort of business district. It's owned by a firm called British Land, who are a major developer here in the UK. And they own not only this building, which sits right to the north of their estate, but they own about half a dozen other buildings that sit in this estate. And this is one of the last buildings they're refurbishing. And it's going to be a real flagship building for them. Not only are they really engaged with the topic of thermal comfort, they're really looking for this to be a low carbon building, and they've really pushed all of the consultants to be as innovative and collaborative as possible to make this a really state-of-the-art, sustainable, low carbon building where possible. I've listed just some of the key firms. So the architects for this project are 3XN out of Copenhagen. The DP9 and Trium may not be known so well to a global audience. They're specific planning firms here in the UK. And then Ramboll are leading on the main structural mechanical engineering. And one of the reasons I wanted to feature this project is that RWDI led the wind engineering on this project. And when we kicked off the work on this project, the wind guidelines, which were brought out in the summer of 2019, were very much in force. So the client team were very aware of the fact they were going to have to take wind very seriously. And actually, we were brought on board from day one of the project. So I sat in the absolute kickoff meeting for this project, which again is quite unusual in the UK. Often a lot of the specialist services are brought on slightly later on down the line once it becomes apparent and the local authorities start asking for things such as wind and daylight sunlight. But British Land, being quite a progressive developer, along with 3XN as architects, were very keen to have us on board from day one. And we worked with them quite closely. As you can see, the towers are significantly taller than their surroundings, which means they do bring some strong winds down to ground level, and we had to work quite hard to mitigate those. Within the City of London wind guidelines, when a building exceeds 50 meters in height, which this one clearly does, you're required to undertake both physical testing and computational fluid dynamics modeling. And the city asked that these are undertaken by separate firms. So RWDI undertook the physical testing and Ramboll's computational team undertook the computational fluid dynamics modeling. And the submission for planning for this project actually went in December of 2020, so just after the thermal comfort guidelines became official. But because both ourselves and Ramboll were involved in writing the guidelines, we were able to advise the client that this was coming. And actually, the results I'm going to share are Ramboll's results on the thermal comfort side. So I'll give you all a moment to look at this. The existing building or baseline conditions are shown on the left-hand side. And it's quite a low-rise building. I forget the exact height of the building that's currently there, but it's probably no more than sort of 10 stories. And then with the new towers with 2 Finsbury Avenue constructed is on the right-hand side with the scale that Ryan shared with you. And key for the client here was not only compliance, because obviously having a compliance scheme works really well with the city and it makes it very easy to get through the permitting process, but because British Land own pretty much all of the buildings you can see, and I don't know if my mouse shows, but pretty much all of the buildings in the block that sits on the bottom right hand side, sorry, of the 2 images is owned by British Land. They have 2 large public squares, Broadgate Circus and Finsbury Avenue Square. So Broadgate Circus is in the bottom right and has a sort of circular design to it, and that's quite far from our new building. But Finsbury Avenue Square is directly flanked by the building that we're proposed to work on. And British Land as a developer actually have become really engaged with this idea of thermal comfort, and with the idea that really understanding the impact that their development has on thermal comfort will affect how they use this space. So currently, this square is used for food and beverage. It has some quite high-end restaurants that open out onto it, the ground floor of all of these buildings. Obviously, there are receptions and entrances to the commercial buildings, but they have a number of very nice cafes and restaurants that spill out into these spaces. They also wanted to understand if they could activate this square going forward. So the images that we have here were the images that were submitted for the planning submission, but actually RWDI has been retained continually on this project and more widely by British Land to look at the whole of their estate now, because they've really engaged with this idea of thermal comfort and really engaged with the fact that better understanding the thermal comfort, not just wind and daylight sunlight, is important for them. And it's important for them for many of the reasons actually Ryan mentioned, financially, in terms of they want this to be an estate that people will come into, that high-end businesses will want to rent spaces from them. And just to give, I guess, another idea of the city, as I said, this sits sort of slightly to the north of the financial district. Beyond north of this scheme is an area we call Shoreditch, which is where a lot of the more design-led firms are. So a lot of the tech startups are based in Shoreditch, a lot of the architectural practices, a lot of the graphic design firms. So the Broadgate estate is really an old school finance meets this new hip culture, and British Land are really looking at how they can bridge that, and one of the ways they want to do it is by having these high quality public spaces. So that's the reason I wanted to share this project with you. Not only do I think the building is architecturally stunning and it was a pleasure to work on, but it was been a really nice legacy for us because it's shown how these guidelines can really inspire developers to make better use of their spaces. The second project I wanted to use as a case study is called 100 Fetter Lane. This is a project that I worked on in 2021, so last year. And this building sits just shy of the 50-meter mark. So in terms of wind engineering, RWDI were the sole wind engineers on this project, and we used computational fluid dynamics for that wind modeling. The developer in this case is someone called the Third London Wall. Fletcher Priest are the architects. Again, we have DP9 as planning consultant along with Watermans, and HED are our landscape consultants on this project. And again, this is a commercial building, and I guess it should be noted that the majority of buildings within the City of London are commercial. So office with some food and beverage and similar at lower levels. There are a few residential schemes, but they're not frequent. And the main feature for this scheme is that it has a series of terraces all the way up different heights of the building. And I think it's intended that this building will be let on a floor by floor basis. So you'd have a different business occupying each floor, and each business might then take one terrace that they'd have for use of their workers to get some fresh air at lunchtime or to sit out on. I'm going to initially talk about the wind results. So the impact of this scheme at ground level was negligible in wind and thermal comfort terms. The existing building on the site is of a similar height. And at 50 meters, actually, this building is not significantly taller than its surroundings. So in terms of our wind assessment, it was quite a boring project to work on, which is good for my client and good for the developer and good for the planning permitting, but not so interesting for me as an engineer. But the upper level spaces, of which you can see here, are quite numerous. And in terms of wind conditions during the summer season, we would be targeting, if we look at wind alone, either frequent sitting or occasional sitting, which is the grey and the blue. And as you can see quite clearly, the majority of these upper level terraces fail in wind terms. They're too windy. And that's, although the scheme is not significantly taller than its surrounds, it is taller and it has a lot of sort of hard edges. So we're getting a lot of wind streaming off those corners. You can particularly see that we've got a yellow patch on the sort of L-shaped terrace. And we worked very hard with the architect and with the landscape architect to develop the balustrade design and to develop the planting strategy to mitigate these winds. But even with extensive planting, just due to the exposure and orientation of these terraces to the prevailing winds, there were quite a number of them, which in pure wind terms alone would be considered a failure. Now, in permitting terms in the UK, because this is a commercial office building and these terraces are not accessible to the general public, it wouldn't necessarily mean that the scheme would be rejected, but it does feed into the overall viability of the scheme, and it is something that the City of London do take notice of, and they do want to be considered, because having a developer build a building which promises great amenity. I mean, this building has a ton of external space that's not really actually usable. Again, it doesn't play into this world-class city. So it's not an automatic fail like it would be if this was a viewing platform or a public space at ground level or a residential amenity where the stakes are much higher, but it is part of the conversation to be had with the city. So that's the pure wind results, and that's what up until the end of 2020 would have been the sole consideration for permitting. However, when we look at the thermal comfort results, we actually see that the conditions are a lot better. They're still not perfect, and that became a conversation that had to be had with the city. But when we take into account the fact that actually this large terrace, which was their top floor terrace, is south facing, and that means it gets a considerable amount of sunlight throughout the year. The fact we have quite breezy conditions on that terrace during the summer season is offset by the fact we've got a really good solar exposure. And actually that space is predicted to be quite comfortable. We're not getting the all season everywhere, but as Ryan mentioned, for a terrace which we're expecting to use during the summer season, actually that's a good result. The blue patch on the sort of P-shaped terrace there is still not as desirable as we would like, but again, it's a large proportion of the terrace is very usable. The space is safe in terms of wind. So we were able to have a conversation with them that said, well, yes, you can imagine that people would go and stand out and walk through that narrow part of the terrace, but they'll still be able to sit out in the larger space that's afforded, because it is a very, very large terrace. So people can move around, use different spaces throughout the year. So the thermal comfort guidelines here for us really proved their worth, because they allowed us to have a conversation with the city that took into account the daylight sunlight overshadowing as well as the wind. The small terrace that sits to the northeast, which is all green, it's all season, actually failed in terms of its overshadowing. It doesn't get 2 hours of sunlight on the 21st of March for 50% of the area because it's north facing. So it is overshadowed by its own building, but it's also the calmest in terms of wind. So again, you get that trade-off. It won't be as well daylit, which actually had more implications for the landscape consultant in this case of what they could grow on that terrace. But it is very, very well sheltered in terms of wind. So it's going to be quite a different environment again, but probably quite a comfortable environment. It's not lacking in light. It just doesn't get that direct sunlight. It's getting reflected sunlight. And the other thing that we're able to do, and Ryan showed some of these plots at a bigger scale, is really do a deep dive into what time of year we're seeing those issues. So within the reporting that we do for the City of London, and due to the fact we did a lot of training with their officers, they have a good understanding of what this means. We're able to say, well, if we look at it seasonally, what percentage of the hours have acceptable comfort? And you can see that in the summer season, actually, the majority of the spaces, or all of the spaces, are comfortable at least 90% of the time. For the majority of them, it's 95%. And those failures come in the spring, and the autumn, and the winter, where we're seeing much lower levels of acceptable comfort, mostly driven by the wind speeds coming off that building corner. And this really allowed the city to make an informed decision about what the conditions would be like on this terrace, and then to allow this building to get permitting at the latter end of last year. So that's what we wanted to share with you today. We have about 10 minutes left, and we'd be very happy to take any questions.
All right. Thank you very much, Ruth and Ryan. And at this point, we'll open the floor up to questions. If you have a question, please go ahead and type it in the chat to one of the moderators. And I also want to take this moment to remind you that IBPSA or AIA Continuing Education credit is available for today's webinar. You can email info@aiaeb.org to receive credit for today's event. While people are typing up their questions, I want to start with one of my own. I'm wondering, you've mentioned that there were a number of things that people had to get used to in these new standards, and potentially that some of the new requirements involve more rigorous modeling than what designers were previously doing. How did firms react to these new requirements? Did they generally find that they had the capability to do this work, or was some form of training required for them?
Should I take that first?
Yeah.
So I'd say within the planning process, there are a large number of firms. So the money sits with the developer. And any additional assessment a developer has to do, they're going to be unhappy about. And that was one of the real pushes on the guidelines, was to reuse the wind methodology. So that wasn't a new assessment that had to be undertaken. And to start to have conversations with developers really early on to say, no, this really is in your benefit. The last case study I gave showed where they would have had a fail, but because they did the thermal comfort assessment, actually we turned what was a bad story into a good story. So working with developers was probably the biggest challenge, because it's all about the money for them. It's all about how quickly they can get through the permitting process. For the various firms that advise, we call them planning consultants in the UK, as part of our work with the city, we actually ran a CPD campaign with them. Not all the firms took us up on it, but a number of the firms had a CPD session, and this was very non-technical. A planning consultant is interested in planning policy, so they can then advise the developers and the other clients of what's needed. So we ran a number of those sessions. But I think your real question was probably more for how consultants such as ourselves took to these guidelines. And I would say it was incredibly varied. There were a large number of consultants who took to it immediately. They were very well tooled up. They undertook a lot of thermal comfort assessments already. A number didn't use UTCI as their first choice. For a range of different reasons. So they had to tool up in terms of shifting from, say, an SET approach to a UTCI approach. But that, if you're already experienced in thermal comfort, isn't a big shift. There were other consultants who I think found it very, very challenging. There are a number of consultants out there who were pure wind or pure daylight, sunlight and overshadowing, who didn't have those transferable skills. And a number of those pushed back. Particularly, we saw a few of the very wind-focused CFD firms. And in the UK, computational fluid dynamics modeling is a very popular tool. And we see a lot of firms who've come from an automotive and oil and gas background moving into the construction industry space. So they have a very, very, very strong aerodynamics and computational fluid dynamics background, but they don't have that building physics, daylight, sunlight, thermal comfort background. So I think a number of those really struggled and had to tool up quite quickly. And we actually saw a number of people move firms. So I think a number of people strategically recruited actually to fill in that gap. Once they became aware that thermal comfort was going to be something that was going to be required to stay on these projects.
All right, thank you. We have a question coming from David. David, would you like to ask your question?
Yeah, just to follow up on that, what softwares, simulation platforms were you using?
Personally, within RWDI, we are primarily OpenFOAM based. We have bespoke tools that we've created within that toolkit. But really, one of the goals we had with the creation of the guidelines was to avoid mandating software. What we did instead was mandate a level of technical rigor that needed to be followed. So we were trying, kind of to this earlier question, one of the goals was to not be gatekeepers. We weren't trying to make something so inaccessible that only a couple of firms could do it. So I mean, there's other consultancies could be using completely different processes for running these analyses, but we have bespoke tools that we've used.
So these are all like CFD software packages that were developed in-house.
No, I'd say a lot of the firms are using a standard CFD package. So that might be ANSYS or STAR or OpenFOAM.
Okay.
Combined with something that's radiance driven. The majority of firms that I speak to, their daylight, sunlight overshadowing is either pure radiance or radiance through a Rhino plugin or something similar.
Okay. Is there like an ASHRAE 209 type standard for where you set a number of guidelines on what must be included in the model?
It's a little more qualitative in our guideline in the thermal comfort and the wind guidelines. It's more like for CFD, it doesn't specify turbulence models. It just says it needs to be at least 2 equations, and that was kind of the same approach we took. So we don't mandate how you simulate the sun, but it just needs to do better than the overcast sky distribution, let's say.
Okay, and that's, I think, one of the real challenges of writing these guidelines is we wanted to set a minimum standard almost to cream off the people who didn't really understand what they were doing. There's again quite a culture in the UK of a lot of firms picking up CFD tools that might be attached to an energy modeling package, for example. And those CFD tools aren't actually very robust for a wind assessment. I'm not passing judgment on their use for other applications, but they're not robust to model wind turbulence. So the wind guidelines do set quite a number of minimum standards, particularly in terms of mesh resolution and turbulence model. They don't go so far as requiring transient modeling for the wind, although it is likely that an update will come in the next year or so that will push in that direction. And that was more, again, it's been a real balance with these guidelines between raising technical standards, which we as consultants naturally want to do, and the commercial realities. If the city set guidelines that are so impossible to achieve that it costs hundreds of thousands of pounds to undertake these assessments, then they'll get a pushback from the developers. And they want the developers because they want the world-class buildings. So it's been a real commercial technical trade-off.
The last question, what was the added cost for this simulating, like a percent of project budget?
On project budget, it would be negligible. I mean, a wind assessment, it really varies, and I'm not going to give actual amounts of money, but it varies. A very straightforward building might be sort of $10,000 to $20,000 for the wind simulations. I have a scheme at the moment that's a 270-meter high tower in the City of London, and it's struggling to show acceptable wind conditions. And we're again with the physical testers for that one. That one's been in the wind tunnel probably 50 times. And there's a partner CFD firm also undertaking CFD in parallel. And the bill on that project, as you can imagine, is running into quite a high number. But the thermal comfort add-on, typically because the results aren't particularly controversial and help to tell the story, is of the order of less than sort of $10,000. It's not significant on a project budget.
All right, thanks for those questions, David. Following on to that, this is a question from Victoria for Ryan. Ryan, you mentioned that there was a paper from the last IBPSA conference related to this work. Is that publicly available, and are you able to share it with our audience?
It is in the proceedings of the World Conference. I believe I have posted it on my ResearchGate page. So that might be the easiest place to find it, but I guess the official source would be the proceedings from last year's World Conference.
All right, thanks. And we have a question from Nicholas. Nicholas, do you want to ask your question?
Sure. Hi there. So my question is about mitigation and how the wind and thermal comfort results would interact in terms of recommending mitigation. For example, if the wind results showed that quite a poor microclimate, but the thermal comfort results told a different story, which would take precedent in terms of whether mitigation is necessary or not?
That's a really great question. So on wind, we consider two aspects. We consider strong winds, which relate to how safe the environment is. And if you have an unsafe wind environment, that is unacceptable, black and white, has to be mitigated. There's no real negotiation or debate there. On the comfort side, the thermal comfort guidelines do consider all spaces. So we're looking at ground level spaces, elevated terraces within our development and on surrounding buildings. That's where it becomes very much a conversation with the city. And I think one of the things about planning permitting in the UK is there are very few hard and fast pass and fails. So the example I gave with 100 Fetter Lane, the wind results on the face of it appeared to be a failure, albeit in a space that the city officers probably weren't that concerned about. So had the scheme been 100% perfect, no other significant effects, pro-politically, pro-financially, architecturally acceptable, some slightly windy terraces wouldn't hold a scheme up. However, if cumulatively it was slightly windy terraces, and there were, I don't know, heritage impacts or traffic impacts or ecological impacts or air quality impacts or whatever else, then the city would say, well, there's an accumulation of problems. You need to redesign your building. Thermal comfort now feeds into that conversation. So for 100 Fetter Lane, on the face of it, the wind results showed a number of those terraces were not acceptable based on the City of London guidelines, based on the Lawson criteria. But when we look at the thermal comfort, it says, well, actually, because they're so exposed to direct solar, that's south-facing terrace, actually the thermal comfort results offset the wind results. So in that case, thermal comfort trumps wind when we're looking at amenity spaces such as terraces. And that's the purpose of having those thermal comfort guidelines, is to contextualize the wind. Because otherwise we're looking at wind and solar as two very, very separate topics. As I mentioned, that north terrace failed in terms of its overshadowing, but actually because it's so calm in terms of wind, it's actually thermally quite comfortable. One of the things we think will come in the future, again, probably a number of years away, is air quality, because you can have a perfectly comfortable climatic condition, but if you're sat next to a busy road, that maybe if you have very low wind speeds, you've got a stagnant environment, that pollution will build up. That then also feeds into the conversation, and that's something we're starting just to see come in the UK in terms of a new air quality positive assessment that is out for consultation at the moment.
Okay, great, thank you.
Thanks for that question. Please remember, if you have a question, go ahead and type it into the chat. I'd like to expand on Nicholas's question a little bit, actually. It strikes me there might be a difference between a case where low wind is offset by shading and a case where a high wind condition is offset by presence of sun. Lawson criteria will still define areas as being too windy for long periods of sedentary activity, because, for instance, they would make papers rustle. Does sunlight offset that, or would a space that's too windy for long periods of sitting remain too windy for long periods of sitting, even if there is a lot of sun?
Yeah, that's a very good question as well. Yeah, Lawson is more about the mechanical action of the wind on other elements, like moving papers around. Whereas we're just looking at the thermal aspects of it. So again, I think this goes back to Ruth's point that it then forms the basis of a conversation where, you know, maybe now from the city standpoint, okay, it's fine, but the developer will now say, okay, well, we'll put some small scale mitigation in here, slow the wind a little bit, while not making it too stagnant, just to make sure people can really enjoy that space. But it would really depend on what that space is ultimately used for, and the conversation that you'd have around that.
And I think it's the same on impact of surroundings. If a cafe space, for example, which has a very specific use, would probably be of greater concern, because you're impacting an existing business, assuming that's an existing cafe. That's a very specific use of that space. Whereas a large public square or a large park, what we saw with the Finsbury Avenue scheme was the net change to Finsbury Avenue Square was negligible, but the areas that were the highest level of comfort moved. So it kind of all swapped around a little bit. And that then became a conversation from the city's point of view. It's not impacted because overall that space is performing the same. But from the developer's point of view, if they've got their highest end restaurant that's charging, you know, probably millions of pounds worth of rent every year, then that for the developer becomes a really key conversation. And it very much then depends on the quality of the client and the design team and how much they actually care about the space.
All right, well, that sounds like a great conversation to have, and I hope that this work inspires many more conversations like it. Thank you, Ruth and Ryan, for giving us this presentation, and thanks to everyone for joining this IBPSA-USA Research Committee webinar. If you enjoyed this webinar, please consider joining the IBPSA-USA Research Committee. You can find out more about the Research Committee by going to the link provided in the chat. For those of you watching us on YouTube, please like this video and subscribe to our YouTube channel. And finally, please join us again on February 24th at 1 p.m. Pacific time, when Aaron Boranian and Ben Larson present simulating demand response heat pump water heaters for California code compliance. Thank you, everyone.